All right. Welcome everyone to the 2020 APAC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions you can, and all sessions will be available to replay as many times you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Better Designed Than Sorry, Let's Design Our Database Schema by Liron Amitzi. Hopefully I properly pronounce your last name, Liron. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker will be answering them at the end of the session. If any issues during the presentation, please feel free to contact me as the moderator at any time on the chat tab of the Zoom webinar. Just to make it more clear, if you have any questions to Liron regarding the session, you want to know more about anything, please use the Q&A tab, and Liron will answer our questions at the end of the webinar. If you have any questions of any issues or anything to organizers, please let me know by the chat option of the Zoom webinar. And now, without any more delays, I would like to leave you with this amazing session by Liron. And Liron, I'm just stop sharing and you can start sharing your screen and taking control.
Okay, thank you very much, Francisco. Let me share my screen here. Okay, and start my video. Okay, I think we're ready. Okay, hello everyone, and welcome, and thanks, Francisco. You actually pronounced my name very well. My name is Liron Amitzi, and in this session we'll talk about database design. And on the screen you see my contact information, my email, Twitter, and my website. I'm on LinkedIn as well, so if you want to be in touch, you're more than welcome to use one of these options. So let's start. First of all, a little bit about myself. So my name is Liron, and I'm originally from Israel, which is the small purplish sort of area here in the Middle East. And just over 5 years ago, me, my wife, and 2 kids moved all the way across the world to Vancouver in Canada. So I'm actually far from you as well in APAC. And this is the first time I'm participating or taking part in this conference. So that's pretty awesome. And it's night here, as you probably see at the back. A little bit more about myself. I've been an Oracle DBA over 20 years now, since Oracle 7 in 1998. Most of this time I've been a database consultant working with all kinds of different clients, from designing and implementing high availability and DR solutions, schema design, SQL tuning, whatever, anything in the database basically that the clients need. I also have my own website, gotodba.com. You're more than welcome to go and have a look. I have a technical blog there, mostly technical, not only. I have other stuff as well about being a consultant and becoming a speaker and all kind of other stuff that you might find interesting. And I've been very involved in the community as well. I'm here in Vancouver. I'm the president of the British Columbia Oracle User Group. And I've been part of the Oracle ACE program for quite a while, and I'm an Oracle ACE director. So let's go to the session now. So the session today is about database schema design, and there are lots of sessions and many things to talk about schema design. My session here, the goal is to make you think. okay? To open your mind to different options or different things maybe that you didn't think about, and give you all the options so you can, think about this stuff when you go and need to design a schema for a new application or existing application that needs some change. So let's begin with what is a schema design. Basically, this session will be divided into two parts. So the first one will be probably a bit less than a half of the time, and we'll talk about the schema design, and then we'll see some examples, and we'll see some concepts. And this is very, let's say, common. And the second part, we're going to talk about a specific problem or challenge, and we're going to see different designs to solve the same challenge or the same problem. And by that, we'll see all the pros and cons of different options. So we'll start with schema design goals. So the goals are, first, store and retrieve data. When we are designing a database, we're using a database. The goal of the database is to store the data and then allow us to retrieve the data, right? So if we design the tables and the structure in such a way that we can put as much data as we want, but we won't be able to query it because it will be too complex or too slow or too whatever, we miss the point, okay? And the other way around, if we can query everything, and if everything is so flexible and so fast, but it will require so much processing or so much, difficulties in entering the data into the database that it won't be feasible, again, we miss the point. So first of all, we need to be able to store the data and retrieve the data in reasonable amount of time and effort. The second thing is data integrity. Okay, so if we have data in the database, we want it to be correct. Okay, if we can pour data into the database, but then the data is corrupted or has all kinds of different problems with the accuracy of the data, again, this is a problem. Okay, so we have to make sure that the data that we put into the database, it's the correct data, and it's consistent, and the integrity is kept. The next thing is the performance. Okay, we would like to have good performance. Now, good performance can be defined by the user, and we'll talk about that a bit later. But it doesn't matter how you define performance, it needs to meet the performance requirements. Okay, if it's an OLTP application, and we need, we click through screens, and every screen takes like 10 minutes to load. It wouldn't work, right? So we need good performance. And the last thing, we need flexibility. Okay, in some cases we will need more flexibility than in other cases, but flexibility is something to consider. And what I said here, these are not hard rules. These are things to think about, okay? And the thing is that every application is different. Every need is different. You need to match these requirements to your application design. And the same sort of application, but with different needs or different requirements, might result in different design that will meet these specific requirements, and this is what we're going to talk about in this session. So what does it include? When we say schema design, what is schema design? Okay, so there are 4 things here, and we'll dive into each one of them in the next few slides. So data types and values of the data itself, indexes on the tables and normalization. Now, tables and normalization is usually what people think about when we say schema design. We'll talk about that as well. And last is constraints and triggers on these tables. So data and values and data types. Okay, so we have here an example of a table which has the lowest temperatures, in this case in Fahrenheit, even though you used Celsius, like I do. lowest city and lowest, sorry, the city, the lowest temperature, and the lowest temperature date. Okay, so if we look at that, we have two things that are maybe a little strange here. The first thing is this. You see the ID, the city, the low temperature date, and the low temperature itself. Everything is varchar2. Okay, so everything is in the database as text. And this might be a problem because, first of all, we talked about data integrity as well at the beginning. We cannot enforce here that the lowest temperature in Fahrenheit won't be a number. Will be a number, sorry. Okay, we need to enforce that the temperature is number. And here we cannot do that, right? The database will not enforce that. You can enforce that in the application level, but then if you create a different application that accesses the same data, they can, enter characters, right? Because it's a string data type. Okay, so this is something to think about. And also, this is a problem with the optimizer. Okay, there are tons of information about that, how the data types affect the optimizer and the database. I'm not going to go into that today, but you should know that if you keep dates as varchar or keep numbers as varchars, there are quite a few implications on that. So this is a first thing that looks strange. The second thing is this. This is not a valid date. This is not a valid temperature, right? So how come? I've seen, in multiple cases, I've seen developers that decide instead of having null values for value that means I don't have this data or this data is, I don't know, not applicable or something like that. Instead of having null, they decide to have an invalid value. So in this example, 1st of January, 9,999, and the lowest temperature is minus 9999. Okay, this is obviously an invalid value. And then they say, okay, my application knows that when it sees invalid values, it will consider that as a null or not applicable. Okay, but this is a problem, first of all, again, because of the optimizer. And second, you need to make sure that all the applications that access this database know that. And if they don't, it's going to be a mess. Okay, so just think about that. When you design a schema, you need to think about these things as well: the data type and the data type length and the values themselves that you put into the database. Another example about data values and data types is this. True story. I've seen it, I don't know, a long time ago, probably 15 years maybe. So a table, let's call it events. It has year, month, and day. And as you can see again, these are varchar, which is a problem. We talked about that in the previous slide. But when I look at the data, this is how it looked. Okay, so in this case, year, month, day, I would expect to see year 2020, year, month, January or 01, and then day 01. But what they used is the year was 2020, but the month included the year and the day included the month. Okay, so this is a problem. And again, we had a huge optimization issue with that. This messed up the optimizer completely, and there are ways to overcome this. But if it doesn't make sense, don't use that. Okay, and this is part of the application design or the schema design. Schema design that is also related to the application design. And together we need this, not to allow these type of things to happen. Okay, so this is another thing that you need to consider and think: what are the columns and what data are we are going to put into these columns. Next, indexes. So indexes, there are lots of things to talk about indexes, and there are complete sessions only about indexes. But here, when we talk about indexes, when we design a schema, we need to consider what columns and what tables should have indexes. What type of indexes? Okay, B-tree, bitmap, composite, the order of the columns. Okay, in composite index on more than one column. the order of the column is important. And maybe function-based index. How many? Enough so queries, and the right ones, so queries will run fast, but maybe not too many, so insert and delete will be affected. So we need to consider that as well. And again, there's no right and wrong answer. There's only answer that is suitable for your requirements or needs. And with indexes in the autonomous DB, when we all know the Oracle Autonomous DB, and in the Autonomous DB, Oracle is starting to handle that automatically. So there's the automatic indexing, and maybe in the future we won't have to worry about that at all. I don't know. But for now, this is something that we need to consider and decide how to do and what to do. Next, table normalization. So as I said before, when I talk about schema design, or when people mention schema design, usually this is the thing that they are talk about. And table normalization is a huge topic. It is, they teach that in university. There are formal ways to normalize data. I'm not going to get into this at all. I'm just going to give a quick overview on table normalization so we can move on. But this is a key thing to design when we are designing a schema. So in this case, we have the employee table, we have the employee ID and name and department and city and state. And the concept of normalization says that entities that are different, separate entities, will be separated into different tables. Okay, so in this case, if we talk about this table, this is the employee table, and departments might be a different entity. So instead of having the text here, IT and sales, we'll just create a new table called departments, and then we'll just have a sort of a pointer from the employee table to the department. And now when the department is an entity, we can add more information. For example, location of the department and the manager of the department, and it makes sense to separate that into different tables. And we can do the same with the city and or state. So in this case, I took the city, I separated that into a different table of cities, and we have the city ID and the city name and the state, and we can also do the same with state and so on and so forth. Okay, and one of our decisions when we design a schema is how to do this. Okay, should we do this in some cases? Should we not do this in other cases? How should we separate the entities into different tables? And we're going to see an example later. And one more thing about table normalization is an incentive for that. And this is a real story from 1992. A city in California called Grover City decided to change its name into Grover Beach instead of Grover City. So if we take the employee table from before, the employee table had a city and state, right? So if we had, I don't know, a few hundred, a few thousands employees that lived in Grover City, now we need to change the name of the city from Grover City to Grover Beach. Okay, so in the first case, we'll update the employee table because the employee table has the city in it as text, and we need to update all the cities from Grover Beach to, from Grover City to Grover Beach. But in the second case, after the normalization, when we have a cities table, we're going to update the cities table and change the city name. And this is basically only one row instead of, potentially much more in the employee table, which would lead to a problem with the updating the data and locking rows, and also consistency of the data, because maybe some of the employees are using Grover Beach already or Grover City, or they write the city in a different way as well. So this the fact that we normalize the data and we split the tables into the cities into its own table allow us to keep the integrity of the data and have standardization in this case. Okay, the last topic is constraints and triggers. So in order to enforce data types and values, we can use constraints, for example, and data types. I said at the beginning that if we have a number, we should have a number data type of this column and not as this column data type and not a string or varchar2. If we have number, automatically Oracle will not allow us to enter any character that is not a number, right? So in more sophisticated cases or more unique cases, we can use constraints for all kind of integrity enforcement. So data types and values, for example, if I have true or false or 0 and 1 are the only valid options, we can easily have a constraint to verify that these are the only values that will be entered into the table or into this column. Also, foreign keys will enforce parent-child relationship. Unique key and not null keys will enforce uniqueness and not null. And if you have some more complex scenarios, you can always use triggers in order to validate that the data is correct and the integrity is kept. Okay, so this is also part of how we maintain the integrity of the data. In some cases, I will change the table structure just not to use, just not to need a very complex triggers, for example. In other cases, I will say, okay, I'm willing to live with very complex triggers, and this is how I want to design my tables. And a very general example and a simplified example of this is the classic OLTP system, online transaction processing system, versus the data warehouse system. So usually when we're talking about saving space, in OLTP, we would want to avoid duplicates. In data warehouse. We don't care about duplicates that much, and we will compress them. Data integrity in OLTP is more important. In data warehouse is less important. And it doesn't mean that in data warehouse we don't care about data integrity, but usually in the classic data warehouse system, what happens is that we load data from other systems, and assuming that the other systems had the data integrity kept, then we don't need to check that in the data warehouse. Also, data warehouse is usually read-only, so we can maybe validate the data only at the entry point, and then once we validated it, we don't need to, check it every time or have constraints or something like that. Okay, we only make sure that the data is correct when we load it, and then it's read-only, so there's no problem. And normalization in OLTP, usually we would want to normalize the data, meaning splitting different entity into different tables. In data warehouse, because of reporting, because of the way the data is queried, we usually want to denormalize the data and have larger tables with duplicates data. Again, we don't care about that much because it's a read-only system. Contention in OLTP, multiple sessions accessing the same data, the same areas in the database. So we would like to avoid contention so they will not interfere each other. In data warehouse is less relevant because mostly the operation is loading, which is done once or in batches, and querying is reporting, and that's not a problem. And performance, OLTP, usually we would like instant response. Okay, we click a button on the screen, we would like to get results. In data warehouse, that's reports. If a report will take 10 minutes or an hour and maybe overnight even, maybe in these cases it's not a big deal. So again, this is the classical. I'm sure there are tons of examples where OLTP might be more relaxed in some cases, and data warehouse might need to be more strict, and that's fine. But you need to know your application needs and your requirements, and then design the schema based on that. And this is the most important thing here. Okay, so timing is going good, and let's design our schema. So in this example, this is a made-up hypothetical scenario. We would like to write a software for a store called Books and More. Okay, they sell 3 types of products: books, magazines, and audio CDs. Okay, and here you can see all the attributes for each product. Okay, and I underline the common ones. So each product, no matter what type it is, will have a title, will have a date, and will have a price. And on top of that, each product will have 2 unique attributes. So books will have author and number of pages, magazine will have publication and frequency, and audio CDs will have musicians and number of tracks. Now, if you ignore completely the lookup tables, okay, so for example, the author, I don't care that I have authors table on the side and have a foreign key relationship to that. Okay, ignore all the lookup tables. So without the lookup tables, how many tables would you use in order to design this specific scenario? Okay, this is the question. How would you model this, and how many tables would you use? And now we created a poll for that. So hopefully, Francisco, if you can hear me and you can start the poll, that would be great. Awesome. So you should see the poll on the screen now. How many tables would you use? Okay, we'll give you I don't know, a few seconds. Just whatever you think. 1 table, 2 tables, 3 tables, 4 tables, or 5 tables or more. Okay, we'll give a few couple more seconds. Okay, I don't see how many voted, but
6 more people need to vote if they're going to vote. The vote is anonymous.
Okay, so it's anonymous and there's no right or wrong here. Okay, it's just interesting to see. Okay, so I think that's enough. Let's finish the poll, and if you can share the results, because I don't think I can.
Okay, I can see 17% says 1 table, 25% says 2 tables, 25% 3 tables. We have a tie of 2 and 3, and
Yeah.
then 17% 4 tables, and 17 5 tables or more. That means we have a tie of 3 on 3.
Yeah.
In the 1, 4, and 5, and a tie of, oh, now somebody voted and changing things. We have 15% for 1 table, 23% for 2 tables, 31% for 3 tables, 15% for 4 tables on 5. That means we have a tie of 15% for 1, 4, and 5 tables, then 23% 2 tables, and 31% 3 tables.
Okay, that's interesting. So 3 tables most of you chose, but not by a lot. And then 2 tables, and then tie between 1, 4, and 5. Interesting. Okay, so you can close the poll. I think there's an option to finish the poll there. Okay, thank you very much. Okay, so what I'm going to do in the next, now you can see the results. Okay, so we have a winner with 3 tables, and then 2 tables, and then 1, 4, and 5. And what we're going to do, we have 15 minutes. So what we're going to do is to scan these options and discuss the pros and cons of each option. So let's start with the first one, and I'll just explain how I color coded this. Okay, so in all of my examples or solutions, we'll have the blank or white background will be the common attributes. The red ones with the B in parentheses will be the books. So you have also the color code, and also in parentheses you have the letter. Okay, so B is the books, the 2, I don't know, blue or teal or whatever color it is, and the M, this would be the magazines, and the A, yellow, would be the audio.
Okay, so the first option was one big, I call it one big happy table. So there's one table that has all the columns, everything that we need, and simply books will have the two red columns full, and the publication frequency, musician, and number of tracks will be null for books. And then for magazines, we'll have publication and frequency. They will have data, but author, number of pages, musician, number of tracks will be null, and so on and so forth. So every product will be inserted into the same table, but different columns will be null or have values, depend on the data type. Okay? Pros and cons. First of all, it's very simple. It's one table, very easy to maintain, very easy to manage, very easy to understand. Good performance. By the way, Oracle, one table, I found the row that I'm interested in, and all the row is already there in memory. I don't need to join anything. I don't need to go and fetch other data. So the performance here will be good. And this is, I need to explain that this is a very simplified solution. In some cases, when you have a huge amount of columns in the table, you'll start having performance problems, but I don't want to discuss that. I just want to discuss the concept of the design. Okay? The bad things is, first of all, contention. Okay? We have one table. Everyone is going to access the same table. Some of the rows will be in the same blocks. That will lead to contention, and that's not very good for OLTP systems. If I want to change something, okay, or to do some maintenance or on something, on one column or the table or something like that, or maybe one type of product, this is practically a full downtime. Okay, I'm going to affect all the products in the system, not only the product that I'm going to touch or change. Okay, and unnecessary scan of irrelevant data. If I want to scan for a title, for example, I need to scan everything. Table that has a specific, if I know the specific type, still I'm going to scan the table that has everything. So I'm going to scan irrelevant data or unnecessary data, even if I know the product type that I want to check. Okay, the next one would be three tables. And three tables, this is most of you chose this one. And three tables will have a very simple design again. One table for each product. So we'll have the books table, we'll have the magazines table, we'll have the audio table. And each table will have the 5 columns that are common, and the 2 extra ones that are specific to this specific product. Okay, so books will have author and number of pages, audio CD will have musician, number of tracks, and so on. Okay, why and why not? First, it's still pretty simple. Okay, pretty good performance again. Okay, and unlike the first, the one big happy table, it accesses only a relevant product. So if I want to, I don't know, count all the CDs that I have in the stores, I wouldn't need to scan the entire table with all the products. I will only scan the audio table, which is exactly what I need, and that's great. If I'm going to change the structure of one of the products, alter the table itself, that wouldn't affect other products, right? If I'm changing something in the magazine table, I can lock the magazine table. I don't affect anything related to books or audio CD. I'm not going to have null columns, right? In the one big table, I had many columns that are null, okay? And this is, first of all, it consumes a little bit of space, but it mainly makes the table very, very wide, and it can grow wide very quickly, and this can lead to problems as well. In this case, it doesn't happen. I have only the columns that I need in every table, okay? Where are the problems? The problem is a little bit flexibility. When I want to add another product, I need to add another table. okay, and use the application in order to change the application in order to access this new table. If I want to query all products, I need to start, you do stuff like union all or something like that. If I want, for example, count everything that I have in the store, or query all the products that have, I don't know, a certain word in their title or something like that, I will have to start union the tables. And if I want to add another product, I will also need to change this part of the code or the application or the database, if it's a view or something, in order to add this new product into these queries, okay? And the last thing is search for an item with unknown type. If I know I want something that I know the title of, and I want to query information about it, but I'm not sure if it's a book or a magazine, I will have to query twice. Once the book magazine, and once the books table and the magazine table. Okay, so in this case, if I don't know what type I'm looking for, and that I can't access this table directly, I will have to go and scan all the tables in the system. And currently I have 3, I might have more. And this is a bit complex and maybe a problem. The 4-table solution is the normalization, a very classic OLTP, a very classic relational database design. I'm having an item, right? An entity called item, which has ID, type, title, date, and price, all the common columns. And then I have sub or different entities. One is books, which is an item, but has extra columns, author and number of pages. Magazine have extra publication and frequency, and so on. So I have foreign key from the ID in the product table into the item table. Okay, so this is the 4-table solution, right? And the benefit, that's a very classical and straightforward RDBMS design. It's very simple to work with common properties. Like before, I said, if I want to search for an item that is unknown type, I can do that now. I have the title. I can just query the item table, which has all the titles for all the products. And then I can know which product it is and go to the relevant table. Also, if I want to, sum the price of all the products that I have in the store, I can do that right on one item table and not run on or query multiple tables, which is a benefit. It requires more joins. Now, with 3 joins, and we get into the downsides here. Joins is not a problem by itself. RDBMS is built for running joins, and SQL uses joins. But this is a very simplified solution. In a much more complex solution with many tables, and I want to split and normalize these entities into many different tables, the joins can be overwhelming. Okay, lots of joins may lead to difficult optimizer decisions and performance problems and more complexity. Okay, so I'm not against joins per se, but if we get to a model or a schema design that has many joins, that might be a problem. Okay, so in some cases, we would like to reduce the number of joins and maybe try to consolidate stuff into fewer tables. Okay, and the same problem as before with the 3-table solution, adding another product. Okay, again, I have the same issue. If I need to add another product, I will have to create a new table and change the application to use that, and that's some sort of flexibility. Okay, so I hope these solutions, 1 table, 3 tables, and 4 tables, were quite straightforward and easy to understand. And now let's go back to 2 tables.
Hi, Liron.
So
Francisco here.
Yeah.
We have 5 more minutes.
5 minutes, yeah. I have 2 more examples, and I'll rush through them, so we will have enough time for questions if there are any. So the two table solution is a bit more complex. Okay, I have the items tables like before, but then I have properties table, and the properties table has property name, property value. Okay, and as you can see here, I have the ID 1, that's a book, obviously, because it has an author, Stephen King, a number of pages, 7,000. If anyone read Stephen King books, they're usually very big, so 7,000. And then 2 is audio CD because it's a musician and Pink. And let's go quickly through the benefits and the pros and cons. This gives you amazing flexibility. You can add products, you can change the entire structure on the fly without changing anything in the database. The problem is it's very difficult to enforce constraints. It's very difficult with data types because everything can be anything. And what about queries? So I don't have a lot of time, but I'll show you not this one. I'll start with this one. Query where the author is Stephen King and number of pages is 7,000. I need to query the props table. I hope you see my cursor. The props table and get the rows where the author is, where the property name is author and the property value is Stephen King, and different rows where the property name is num pages and property value is 7,000, and then get all the IDs here and query the book. And it gets much more complex when you try to do AND. I'm not going to go into that because I don't have really time, but you can download that presentation and figure out what I did here. It becomes much more complex when you have a more complex predicates. And the last example would be one table, but where the other info is basically a JSON or XML or something like that. And then you can put anything you want here, okay? And the pros and cons here is it's very easy for developers to handle because they use, JSON and XML all the time. It's extremely flexible, but it's not really an RDBMS, and you cannot enforce anything. And that's by definition because this is how JSON and XML work. And this is just an example of querying, just other info.author is Stephen King, other info.numPages is 7,000, and that's pretty straightforward to do. So which one is the best? One tables, two tables, one table, two tables, three tables, four tables, the one with the JSON. By the way, I don't have one with 5 tables. So if you have an idea how to do that with 5 tables, let me know. But the answer is, it depends. It depends on your requirements regarding performance, flexibility, data integrity, querying, and space. Okay? And if we have time, and we don't, so let's jump to the questions. And again, this is my contact info if you would like to, contact me or follow me or anything, I'll be happy to hear from you. And if there are any questions, please let me know. And thank you very much. I don't see questions right now, so thank you very much. I hope you enjoyed. And there is an option to chat on the platform, right, Francisco, on the website?
Yes.
If you have any questions.
On the replay page, the people can watch the replay for 2 weeks, and then they can also post comments, questions over there in your page of your session, and you should be notified by the system. If not, I will do that every 2 days.
Okay, awesome. So I'll be happy to hear from you, and thank you very much. I hope you enjoyed.
Thank you so much. All the best to everyone. Have a wonderful night on your side.